as we discussed, a moving charge, that is electric current, produce magnetic field around it. Okay, and it creates a magnetic field, and if a electric charge moving in the field will experience a force, that force we call, it will experience a magnetic force or we can call it, is named after the force Lorentz force. Magnetic force or Lorentz force. This is called a Lorentz force. That is the electric charge moving in a magnetic field. A charge moving in a magnetic field will experience a force. If this is Q is the charge, we call it as a positive charge. Later we will discuss about negative charge also, because we have to discuss about both the charges, because a charge particle will either be positive or negative, and it moves with a velocity v in a magnetic field. Magnetic field is denoted by B vector because it has got both magnitude and direction. Velocity also has got magnitude and direction. So when a charged particles move in a magnetic field B, it will experience a force. That force we call it as a Lorentz force or magnetic force. Now what about this force? This force, magnetic force, is proportional. Later we will come to the, first we will see the magnitude part, later we will come to the direction of the force. This magnetic force is directly proportional to magnitude of the B. That is magnitude of the magnetic field. That we can write simply magnitude, and Fm is directly proportional to the charge. See here it is plus charge, and the magnetic field is also directly proportional to component velocity. Component velocity of B, component velocity perpendicular to B. That is, the component, this velocity will have two components. If it is moving in one direction, it will have the component velocity. Suppose if we say in the vector product, see this is the plane in which this is the velocity of this one, this is the direction of B. Now making an angle theta. Theta, what is theta? Theta is equal to angle between magnetic field B and that charged particle moving with velocity v. If theta, see now we resolve into the past. See in the trigonometry already we have seen here, this is x, this is hypotenuse, and this is theta. Here we can write this is ABC. This can be written as hypotenuse into this angle is sine of theta. This is hypotenuse into cos of theta. That is, from the angle which is far away, that will be sine of theta. Near to it will be cos of theta, or further we can see, and this will be 90 degrees. This is what we have learned from trigonometry. So here the velocity is moving like this, the magnetic field is like this in this figure. Now if you drop a perpendicular, component velocity perpendicular to B, it means this velocity can be, this is velocity component in this direction, and this is velocity, this velocity is making an angle theta. This is far off, it means hypotenuse into cos theta is its component, because see here from the theta far off, from theta far off will be sin theta, far off, and hypotenuse into nearby is cos theta. That is, here hypotenuse v of cos theta. This is cos theta. So this can be made into two components. One is this direction v cos theta, one is in the direction v sin theta. Why? Because This is perpendicular to B, and this is along the B. V cos theta is along the B, along, and this is perpendicular. So now it is component of velocity B, component of velocity V perpendicular to B. So this force is proportional to, first force is proportional to the magnitude of B, and force also proportional to magnitude, first point and second point and third point. That is, force is proportional to, what is this, what is that component? V sin theta, V sin theta, which is perpendicular, that is V sin theta. This we can write these 3 points, that is F is B proportional to B, F is proportional to E, and F is proportional to V sin theta. Or we can write F, combining all, magnetic force experienced by a charged particle when moving in a magnetic field, because this charged particle is moving in this magnetic field. Combining is equal to Q V Q B into V sin theta. It is proportional to Q, it is proportional to V sin theta, it is proportional to C. Or we can make it as F magnetic field is equal to some constant into Q V B sin theta. This is one component, 2, 3. Now we write in this form, VV sin theta. So to remove, we will remove this, we have to remove this one, or we can write Fm is equal to some constant k into Q into velocity, charge velocity into perpendicular component of velocity in the direction of magnetic field. This is we have written. Now this constant F is equal to K Q V B sin theta. So what will be its value? Its value is equal to 1. The K value of K is equal to 1. K is equal to 1 means what? We can write force is equal to K is equal to 1 into Q into V into B into sin theta we can write, or we can simply write Q V B sin theta. This is only the magnitude of the force. It will have the direction also. So we have written only the magnitude. This is the magnitude. Now we have to find out magnitude. There are several rules to find out. First we will find out what is this one. So now we must have seen in the vector product. So this force, what is this force? We will write only in magnitude, is equal to Q V velocity into B into sin theta. This is the force which gives, suppose a particle, this is the magnetic field, this is the magnetic field, a charge plus Q is moving in this, it will experience a magnetic force. This charge will experience magnetic force due to this magnetic field, and this is called Lorentz force. Lorentz force. So to say first we will find out the magnitude. The force, this is the force which deflects the charged particle and is called magnetic Lorentz force. Therefore we have already discussed that a charged particle moving inside a magnetic field, in the magnetic field, will experience a force that we call it as Lorentz force, which is given in vector form. Magnetic force Lorentz is equal to charge into cross product of velocity vector of the moving particle and magnetic vector of the field. So in scalar form, Fm magnetic force is equal to Fm is equal to Q into V into B into sin theta, because V cross B what? VB sin theta into unit vector along it will come. So this will be equal to Q into V into B, this into sin theta, because it is a vector, this to theta unit vector along this direction. This we will see later part when we see the direction of magnetic force. So Fm is equal to rate charge, velocity of the particle moving in the magnetic field into the magnetic field, magnitude of magnetic field into angle between them. See, this is the magnetic field, direction of magnetic field, and this is the direction. We just take for a trial V, and the angle between V and B is theta. Now, when this will be maximum, see, magnetic force will be 0 and will be maximum on certain condition. That is, Fm is equal to 0 when Fm is equal to 0 when Q is equal to 0. When Q is equal to 0, the entire thing will become 0, and V is equal to 0 and B is equal to 0, and depends upon sign of angle also. So first we will see one by one condition. See, where F, the force F, maximum, the magnetic force will be 0 when Q, V, B, it depends upon, the magnetic force depends upon these factors, all these factors. Now let us see when magnetic field is absent. First, when magnetic field is absent. That is, magnetic field is absent means 0. In that case, what is magnetic force is equal to Q into V. Here we are writing in magnitude form. B is equal to 0 into sine of angle, which is equal to 0. It means the first condition, when B is equal to 0, the net magnetic force on a moving charge is equal to 0. When first, if the charged particle is at rest. Second one, if the charged particle, if the charged particle is at rest, that is, velocity of the particle is equal to 0. It is not velocity of the particle is equal to 0 because inside the magnetic field the charge is at rest. It is not moving. Only moving particle inside the magnetic field experience a force. If the charge is at rest, V is equal to 0. So this is equal to 0. The force maximum is Q into 0 into B into sin theta. That condition also, magnetic force is equal to 0. The second one, when theta is equal to 0, that is when this is, you see, third condition, theta is equal to 0, it means sine of theta is equal to sine of 0 degree is equal to 0. It means what? What is the condition? This theta is equal to 0 means what? If the theta is equal to 0 means the angle between them is equal to 0. It means the magnetic field vector B and V are together. It means in this condition only theta is equal to 0 degree. When the particle moves along the direction of field, when it means, that is, when particle move along the direction of magnetic field. This is condition A. Condition B, if theta is equal to 180 degree, that is sine of 180 degree is equal to 0. That condition also 0. If the theta, it means the angle, suppose this is the direction of B and this is the direction of motion of the particle, the angle between them is 180 degree, that is anti-parallel. Anti-parallel. B is in this direction, velocity is in the direction, the particle moving in anti-parallel direction with B. So in this case, sine, if theta is equal to 0, sine of 0 is equal to 0, Fm is equal to 0. If theta is equal to 180, sine of 180 is equal to 0, it means entire thing is equal to, in that case also, magnetic force is equal to 0. And the next one is, if the particle is neutral. If the particle is neutral means what? If the particle is neutral, we can say if the particle is neutral, if the particle neutral, Fm in magnitude is equal to charge into its velocity into magnetic field into sine of theta. If the particle is neutral means charge is equal to 0. Either it is positive charge nor it is negative charge. It has got no charge. No charge means what? Fm. This is equal to 0. Therefore, Fm is equal to 0. In this third and fourth condition, Fm is equal to 0 if the charged particle is neutral. Fourth condition. Then fifth condition. Fifth condition, there will be one more one. When particle moves perpendicular, when this particle moves perpendicular to the direction of magnetic field. See, this is the direction of magnetic field. If the particle is moving perpendicular, particle with a velocity move and the direction is 90 degree. Need not to write, it indicates 90 degree. That is theta is equal to 90 degree. Sine of 90 degree is equal to 1. Because sine of 90 is equal to 1. If that is if the particle is moving perpendicular to the direction of B. Perpendicular to the direction, then magnetic force is equal to Q into V into B into sine of 90, which is equal to, this is equal to 1 Q into V into B. That condition, the magnetic force will be maximum. When will be this will be maximum? The magnetic force is given by this expression. When this force will be maximum, this is equal to 1. If this is value gives negative value, or if its value is equal to 0, it will give another value. When this expression will be maximum, when this is equal to 1. Therefore, what we can say under this condition, when the particle move in a direction perpendicular to the direction of magnetic field, then theta is equal to 90 degree and sine 90 is equal to 1 and force is equal to QVV. F magnetic force is equal to Q into VB is equal to force maximum. Fm maximum. You can say a particle moving in a magnetic field, and if it is moving in a direction perpendicular with the direction of magnetic field, the magnetic force will be maximum on the particle, and which is equal to QVB.